Hi, welcome to the channel. My name is Keith, and today we are going to talk about how to spot check your test equipment prior to doing a tape deck alignment. Now, I know that there's lots of different types of test equipment. Some people have specialized equipment. Some use, like myself, use just general purpose equipment. But either way, you still need, you should kind of spot check it to make sure that it is in tolerance, so that you can trust and rely on the readings that you're getting from it as you do the alignment. So this is going to be done in two parts. The first part, we're going to talk about how to determine the accuracy of your test equipment. How to compare that to the accuracy of the calibration source. In this case, the calibration source is a Dmm Check Plus device, which I talked about in a previous video, and I will put a link to in the comments. And then we will calculate what's called the test accuracy ratio, or TAR, to see if the calibration source is sufficiently more accurate than your test equipment in order to give you a valid comparison. If you are familiar with all that and you know how to do that, then by all means stop this video and go to part 2. If you're not, or you want to be refreshed, then just give me a few minutes of your time, and we'll work through this real quick, or as quick as I can. So without any further ado, let's look at the equipment that I use. First, this is the Dmm Check Plus device that I talked about in a previous video. It basically, for our purposes, it provides a voltage source, both AC and DC voltage source, and it has other things, but for doing tape decks, that's really all we care about, is the voltage source. So the meters I have a vacuum tube voltmeter over here. I have a digital multimeter down here, fairly accurate one, much better than a handheld multimeter anyway. I have a digital waveform generator and a digital storage scope here. Basically though, during a tape alignment, the only real measurements that are necessary, that you need real accuracy on, are voltage measurements. Either DC voltage, like in power supplies, or AC voltage, which is basically everything else. The audio signal coming out of the output jacks and off the calibration tapes, that's all AC voltage as far as we're concerned. So really all we need to check is the digital multimeter and the vacuum tube voltmeter. You may need, if you don't have a separate flow and water, a wow and flutter meter, you may need an electronic counter to check the speed of the actual speed of the drive motor, to make sure it's turning at the correct speed. And I don't have a wow and flutter meter, but I use software to do that, and I have a little analog, the digital device that takes the signal out of the output jacks and feeds it into a piece of open source software, and it calculates the wow and flutter percentages. So, but for today, we're just going to focus on the two multimeters, the the digital multimeter and the vacuum tube voltmeter. And so let's look at what we need to figure out. First, we need to figure out what the accuracy of our equipment is. And we'll start looking at this list from the bottom going up. The vacuum tube voltmeter is on the bottom. It can only measure AC voltage. The Dmm Check Plus device only puts out a nominal 5-volt signal. So on the vacuum tube voltmeter, we have to measure that on the 10-volt range. So as typical old analog devices, they're only spec'd at a percentage of full-scale deflection. So in this case, it's 2% of full scale on the 10-volt range, which would be 10 volts. So 2% of that would be 0.002 times 10, or 0.2 volts. Which equates to plus minus 2 minor divisions on that scale. On the digital multimeter, though, it's customary to have two sources of uncertainty. You have the actual reading itself, and then you have also a component of the uncertainty that contributes to the accuracy, and that comes from the actual range. So for the AC voltage, it's 0.2% of the reading plus 0.05% of the range. So it would be 0.2% or 0.002 times 5 volts nominal, actually 4.999, plus 0.0005 times 20, because we're on the 20-volt range. And that gives you a total accuracy of plus minus 0.02 volts for the AC voltage. You notice the DC voltage is more precise. So the DC voltage accuracy is 0.00155 volts. So once you calculate that, and you have to calculate it based on the percentages in your manual, using the actual voltage that you're going to measure. So once you calculate that, now you have to compare that to the standard. Now the Dmm Check Plus AC voltage standard is plus or minus 0.1%, or plus or minus 0.001 times 4.999, which gives you accuracy of plus or minus 0.00499 volts, which means that the calibrated value of the 5-volt AC is actually 4.999 volts AC, plus or minus 0.00499. The test accuracy ratio is determined by dividing the accuracy of the meter by the accuracy of the standard. So in the AC case, the accuracy of the meter was 0.02 volts, and so you would divide that by 0.00499 volts, and you get a number of 4. So that means that the standard is 4 times more accurate than the multimeter. In the DC voltage, it turned out to be the standard is 4.4 times more accurate. In the vacuum tube voltmeter, the standard is actually 40 times more accurate. So, but 4 to 1, or 4 times more accurate, is considered the minimum for normal use. You would want to have a standard that is a minimum of at least 4 times more accurate than what it is you're testing against it. And that is it. So if you have any questions about the numbers, or if you found a mistake in my mathematics, yeah, please enter it in the comments, and then we'll see you or in part 2, where we actually take measurements and check my equipment and see if it is in tolerance. That is that's all for now, and take care. Remember, the best way to keep your vintage audio equipment working is to use it regularly. Take care, and bye for now.